Okay students, we got question number 4. Let me write the question down. The line has equation y is equal to 3x positive k and a curve has equation y is equal to x squared positive kx positive 6, where k being a constant. Find out the set of values of k for which the line and the curve have two distinct points of intersection. Okay, so this is the question. Let us solve this question. So what are we given? We are given that y is equal to 3x positive k. This is the equation of the line, and y is equal to x squared positive kx positive 6, right? So what we are going to do is we will equate the two equations. So you have equation 1 and equation 2. So equate the two equations. We get, so what do we get? We get 3x positive k is equal to x squared positive kx positive 6, and from here we get x squared positive kx negative 3x positive 6 negative k, right, is equal to 0. So this can be rewritten as x squared positive. Now what I wish to do is I will write it in this fashion: k negative 3 times x positive 6 negative k is equal to 0. Now for distinct roots, so we are actually looking for distinct points, right? So for distinct roots, the discriminant should be greater than 0. Okay, let me write it in this fashion. So this means b squared negative 4ac is greater than 0. This means a is equal to 1, b is equal to k negative 3, and c is equal to 6 negative k. Utilizing all this, this is going to be k negative 3 the whole square, negative 4 times a is 1, c is 6 negative k, greater than 0. Now what I wish to do is I will have to find the value of k. So let me move to the, I hope you are able to get this. So let me move to the next page. Now to get the value of k, what I'm going to do is I'm going to take the system to be equated to 0. So 4 times of 6 negative k is equal to 0. So this is going to be k squared negative 6k positive 9 negative 24 positive 4k is equal to 0. So this is k squared negative, you add this, you get negative 2k, you add this, this would give you a value of negative 15. I am taking it equal to 0. Now if you were to factorize this and find the value, see for example this is one way of factorization. You have negative 15 and you need to get negative 2 here. So 5 into 3, 5 times 3 gives you 15. We need to get a negative 2 here and a negative 15. So I'm going to take this as negative sign there, right? So if I were to do that, I would get negative 5 into 3 negative 15, and negative 5 added with 3 I get negative 2. Okay, so if I were to write it as a factor, this is going to be k negative 5 times k positive 3 is equal to 0, but we have an inequality. So that is k negative 5 times k positive 3 is greater than 0. So for the inequality to hold good, the value of k should be, see, you got k negative 5 times k positive 3. So in this case, k should be less than negative 3 or k should be greater than 5. So this is the solution for the question. Okay.